Hello students. So far we have learnt all the methods of solving linear equations in two variables. We have learned the elimination method, the graphical method and the Cramer's rule, right? Now it's time for us to deal with the equations where there are variables in the denominator. So far whichever fraction related sum we saw, they had numbers in the denominator. Now let's see what happens when there are variables in the denominator. Let's solve this sum. The question is solve the following simultaneous equations. As you all can see, there are variables in the denominator. 148 upon x plus 231 upon y is equal to 527 upon xy. 231 upon x plus 148 upon y is equal to 610 upon xy. So there are variables in the denominator. Let's see how do we tackle them. The first equation given to us is 148 upon x plus 231 upon y is equal to 527 upon xy. Now when we were dealing with numbers in the denominator, we learned that whenever there are denominators, we multiply throughout by the LCM, right? Now here also, let us try to multiply throughout by the LCM and see whether it works or not, right? Now the denominator is x, y and xy. Right, x, y, xy, the LCM is xy, right. So what we can do is we can multiply throughout by xy to this equation number 1, and similarly for equation number 2, the denominator is x, y, xy, so we can multiply throughout by xy, right. So let's do that. Let's multiply both the sides of equation 1 and equation 2 by xy. What do we get? Look at it now. See, it is getting multiplied by xy. 148 upon x into xy, x gets cancelled, what remains is 148y. Then y gets cancelled, what remains is 231x, and xy gets cancelled. So what remains is 148y plus 231x is equal to 527, and similarly the second equation will be 231 y plus 148x is equal to 610, right. The only thing is, as you all can see this equation, it is not in the alphabetical order. It is 148y plus 231x. So just rearrange it, and when we are rearranging, we don't change the signs. You remember that, right? So let's write this as 231x plus 148y is equal to 527. Let this be the third equation, and the next equation would be, when you are multiplying throughout by xy, it actually becomes 231y plus 148x is equal to 610. So again rearrange, what you get is 148x plus 231y is equal to 610. Let this be equation number 4. Now look at the third and the fourth equation. We were successful in getting rid of the denominator where there were variables in the denominator just by multiplying throughout by the LCM, that is xy. So this is what we did, the two equations in front of us. Now we can use any method that we know to solve the two equations. Now which method is the best here? As you all can see, look at the coefficient of x in the third equation, that's 231, and in the fourth equation look at the coefficient of y, it is 231. So the coefficients are diagonally same. Similarly, look at the coefficient of y in the third equation, it is 148, and in the fourth equation it is the coefficient of x is 148. So again the coefficients are diagonally same, and whenever the coefficients are diagonally same, it is always better to go for the ASA method, the add, subtract, add method that we have learned, right. So let's use it and solve the two equations and get the values of x and y. So let's do it. Let's use the ASA method. As you all can see, the coefficients are diagonally same, right. So let's do it. The first step of ASA method is adding equation 3 and 4. So this is your third equation, this is your fourth equation. Let's add 231x plus 148x. What is 231 plus 148? It is 379x. Similarly, 148 plus 231, 379y. You remember ASA method, after adding or subtracting, the coefficient of x should be same as the coefficient of y. And 527 plus 610 is 1137, right. Then hope you all remember 379x, 379y. Let us divide throughout by 379. So when we divide throughout by 379, what we get is x plus y is equal to 1137 upon 379, which is 3, and we are getting a very simple equation, x plus y is equal to 3. Let this be equation number 5. After adding, getting the fifth equation, now what we do is we subtract the two equations. So let us subtract equation 4 from equation 3. When we subtract equation 4 from equation 3, we write the third equation first, then the fourth equation, and then don't forget to change the signs because we are subtracting, right? So plus 148x becomes minus 148x, plus 231y becomes minus 231y, and plus 610 becomes minus 610. Now let's do it. 231x minus 148x is 83x. 148y minus 231y. Again, the bigger number is having the minus sign, so it will be minus 83y. Again, the coefficient of x same as the coefficient of y, and 527 minus 610 will be minus 83 because again 610, which is a bigger number, has got a minus sign, right? 83, let's divide throughout by 83. What we get is x minus y is equal to minus 1. Let this be equation number 6. Add, subtract, now again add, the ASA method, right? But this time we need to add the fifth and the sixth equation. So let's add equation number 5 and equation number 6. Equation number 5 is x plus y is equal to 3, and equation number 6 is x minus y is equal to minus 1. Let's add. When we add, plus y minus y gets cancelled. What we get is 2x is equal to 2. So x is equal to 2 upon 2, that is 1. Once we get the value of x, let's substitute x is equal to 1 either in the fifth or the sixth equation. Fifth is better because of the positive sign, right? Let's substitute x is equal to 1 in equation 5. What we get is 1 plus y is equal to 3. So you get y is equal to 3 minus 1, y is equal to 2. X is 1, y is 2. Don't forget to write the final answer that the solution of the given simultaneous equation is x comma y, that's 1 comma 2. As simple as that.